Excellent. So welcome everybody. My name is Lenny Teytelman. I'm the CEO and co-founder of Protocols.io. This is, just to make sure you're in the right webinar, this is the Protocols.io for pharmaceuticals webinar. And we'll spend about 20-25 minutes introducing Protocols.io and specifically its application in industry, why we exist, and a short demo of the key features of Protocols.io. And then we will have plenty of time for question answer. As you might have heard, this is being recorded. We'll circulate the slides and recording to the registered participants afterwards. So you'll have the slides, you'll have the recording. You don't have to wait for the Q&A to ask questions. We have several people from Protocols.io who are also on this webinar. So as I present, feel free to click on the Q&A in the lower right-hand corner of your Zoom panel and ask questions there. And then when we go into Q&A, the ones that haven't been answered during the presentation, I will try to get to all of them. And if not, you can always get in touch with us afterwards. So with that, let's get started. I'll share my screen. Oh, and Nastya, it says host disabled participant screen sharing. Do you have any way of letting me share screen? Let's try it again. Yep, it's working now. Thank you. All right, so everyone should be able to see the screen. And I am, just as introduction, I am a geneticist and computational biologist by training. And the reason I co-founded Protocols.io, the seed for it was my experience as a postdoc. So I have a PhD from Berkeley and then was doing a postdoc at MIT when I literally spent a year and a half, the first year and a half of the postdoc, correcting just one step of the method that I was using. So instead of a microliter of an enzyme, I needed 5. Instead of a 15-minute incubation, needed 1 hour. And at the end of the day, after that year and a half, it's not a new technique. It's a correction of something previously published. And there was no good way for me to communicate this correction to everybody else who's using the method. There was no GitHub for science methods. So I became obsessed with creating a central place where it's easy to share such method development knowledge. So that's the background for protocols.io. We launched in 2014. And there are 2 sites. For some of you who already know Protocols.io, there are 2 sites. There's an open access repository, just like on GitHub, you have the open repositories. That site is free, open access, free to read, free to publish. And then there is the private side of Protocols.io, which is for internal collaboration within research groups and companies, both in academia and industry. And so this workshop will be focusing specifically on, as I said, protocols for pharmaceuticals. So this will be the private side, and that's the one that is the subscription-based service. So it's free to create a workspace, free to create the first protocols and test out protocols.io. And then if you're sharing them publicly, there is no limit. But if you're using it in private mode, you're limited to 5 free protocols to test the platform. And you can see if you go to protocols.io, I'll highlight some of these examples. You can see that it's not just academia that is using protocols.io, but you'll see a lot of protocols from FDA, CDC, and other agencies. We can't say which pharmaceuticals and biotechs are using us, but one of them is highlighted in our case study. And again, as a reminder, we will be circulating the slides and the video, so you don't have to try to write down the links. And both, the industry and government use, that's both for open sharing and for internal collaboration that we'll talk about in a second. And at the bottom, you can see there are over 500 biomedical journals that actually recommend and encourage use of protocols.io when you submit a research paper. And more funders are starting to do the same. As I said, we launched in 2014, but I don't show the graph of adoption starting that year because it's too depressing. So the first years were pretty rough, but you can see we're on the right trajectory. And at this point, the public open access repository side of protocols.io has about 11,000 public protocols, including versions. And on the private side, there are just over 36,000 private protocols. And as you'll see, we're going to switch over to the demo soon. As you'll see, everything starts out privately. You decide who to share it with, when to share, what permissions to give to them. And then if you're in academia, if and when appropriate, you might make a protocol public to get credit for it and share with others. But academic or industry, in terms of the problem we're trying to address with protocols.io, a really nice highlight for our sort of reason to exist is this initiative called Reproducibility Project Cancer Biology. This was an effort from the Center for Open Science and Science Exchange, a collaboration that started in 2015. I think it was $1.5 million effort to independently replicate 50 high-impact papers in cancer biology. And the project actually finished early because of, to a huge degree, because of the challenges with reproducibility that we'll talk about on the next slide. And you can see that instead of replicating 50 papers, they wound it down at just 18. And a big component of why it was so hard and why they couldn't do all 50 was the missing methods. So on the next slide is one of my favorite stories around this. It was all over the news, but Ed Young, writing in The Atlantic, wrote, "The hardest part by far was figuring out exactly what the original labs actually did. Scientific papers come with method sections that theoretically ought to provide recipes for doing the same experiments, but often those recipes are incomplete, missing out important steps, details, or ingredients. In some cases, the recipes are not described at all. Researchers simply cite an earlier study that used a similar technique." So this is about the published papers that they're trying to reproduce. And then it continues. So in every case, he, meaning the lead of the study, had to ask the scientists behind the original experiments for the details of their work. Oftentimes, the person who actually did the experiments had left the lab, so an existing team member had to rummage through old notebooks or data files. The project ended up being hugely time-consuming for everyone concerned. And what this really highlights is the two sides to reproducibility as we think of them at protocols.io. One is external reproducibility, what's in the published research papers, and can I read the paper and follow up on it? And most of the time the answer is no, in terms of the precise sequence of steps that were followed in the research in the protocols. And the other side is the internal reproducibility. Long before anyone is publishing any papers, what happens inside a research group? And as we saw in this description from Ed Young, the challenge with reproducibility starts long before the paper. So even when the team went to the original authors, they couldn't find the exact protocols. They didn't know what exactly was done. The student had graduated, the postdoc had moved on to another career or another job. And even when the person is there, sometimes it's hard to find for yourself what exactly you did. So our mission at protocols.io is to make it easy to share the method details before, during, and after publication. And the before part is absolutely critical because that's what allows teams to make sure that the knowledge stays even when people leave. And one of my favorite quotes is, "Your most likely collaborator is yourself in 6 months, and the past you does not answer emails." So when we talk about the private collaboration on protocols.io, both for academia and industry, it's around making sure that the method is not just sitting in one of the 1,000 pages of lab notebooks, whether electronic or paper, that there is a central place. And what we found since we launched in 2014 is that, exactly as I said just a second ago, it's not just a problem at universities and academia keeping track carefully of method details. We found at pharmaceuticals, large, small biotechs, we found that very often somebody is using Microsoft Word, somebody else is using an electronic lab notebook, somebody is putting their protocols on Dropbox. And as I said, when that person leaves, good luck figuring out in that research team what exactly was the protocol that was used. So at this point, we've talked enough about the why of protocols.io, but I'd like to do a live demo of some of the, not exhaustively, but some of the key features of the platform. And as I'm showing here, this is a public protocol, but as I said, everything starts out privately and is secure. It's confidential. It's completely up to you who you give permissions to, who you share it with, and whether it's view only or view and edit or co-administrator on a protocol. And obviously I can't show any private protocols. I don't have access to them, but this is one of the 11,000 public protocols on the platform, and the same functionality applies. So it's a good way to highlight the features. So one thing you can notice is that this is not just PDF or text. The protocols have structure. We put a lot of effort into an editor that is concurrent, just like Google Docs, has a history of changes, you know, who changed what with your collaborators. But importantly, it is optimized. We put a lot of effort into making it specific for research protocols, right? So the sections that are in there, if you start to play around, I won't have time on this workshop to dive into the editor, but if you're playing around or you get on a call with someone on our customer support team for an introduction, you'll see that there's a lot in there to encourage detailed reporting of exactly the minutia that you need to repeat your own or somebody else's work. So we have, for example, we have catalogs from reagent vendors, so you can type in a catalog number and specify exactly which reagent, where you ordered it from. We have components for temperature, the data set that you used, if it's a computational pipeline. So there are a lot of components that try to capture, as I said, those details. The steps themselves, you can add attachments to them. So not just text and components, but you can add a Python script, an Excel document directly to a step or on a protocol level. The steps, as you can see, support tables, images, and one of the things we're starting to see more and more of is people adding videos directly inside the protocol steps, and that is gold for reproducibility. So the videos allow you to capture some of the nuances that you might not even consciously think about. But we make it very easy to drop in a YouTube link or take a 10-second, 1 minute, however long you need it, video. In this example, it's 4 minutes with your phone, upload it right into your protocol, and then you or others on your team, when they come in, they can see exactly how you were doing that particular step. So you don't need it for every step of the protocol, obviously, but some of the more nuanced techniques can really benefit from videos. So the protocols are dynamic and interactive. It's, as I said, not just a PDF. And you can see as I mouse over them, I can click plus, which allows me to ask a question. In this example, because it's a public protocol, I can ask publicly or privately. If it's a private protocol inside your company team, obviously it is only between the people, between the author and the people that are using this protocol that are in the workspace. So This allows you to have not disjointed conversations in email threads or on Slack, but to have method development conversations directly on the protocol. And just as in the steps themselves, when you're asking questions, so here is the Q&A on this protocol, there's some protocol level comments, there are some comments directly on steps. And as you can see, you can add images, you can add results and ask, hey, I'm getting this, and ask your teammate, maybe you're in Oakland and your collaborators in Berlin inside your company, but you can communicate and you can capture these conversations and have threads right on the protocol. And as you have these conversations, one of the things you can see in terms of keeping things up to date is the ability to easily version. And this is at the heart of method development for anybody who's done any research. Methods change, whether it's computational or experimental wet lab at the bench. Methods change, our equipment changes, our approaches change, their optimizations. Kids get better and better, right? So Protocols.io is built with that at the core. You have discussions, you can clarify things as you tweak, optimize, and improve your protocol, going back to Lenny's sub story of the postdoc experience. We make it very easy to make a new version, improve what you've shared, capture those corrections and modifications. And you can see on every protocol, there is a compare button that allows you with a click to see between version 1, version 2, what's the same, what's different. So step 1 is the same. Step 2 has been edited between the different versions. And the versioning is for keeping a protocol up to date. But very often you're working on liver tissue, I'm working on kidney or lung tissue, and there are slight variations between them. So just as in GitHub, there's forking, you can fork any of the protocols, private or public, on Protocols.io, and then it becomes yours. And with a click of a button, you can make changes to it. You can edit the specific steps. Very often you might be forking your own protocol because, as I said, you are not making it better or worse. You're not necessarily improving it, but you are capturing the variation. You're capturing the variation in the technique, depending on the cell line that you're using, depending on the tissue, right, and the approach. So everything sort of serves as a template, and the same compare functionality applies not just to versions, but to forks as well. And the last thing, I won't show it on this call, just so that I make sure that we have time for Q&A, but about 5 to 10% of the public protocols that we see are computational bioinformatics protocols. The vast majority are wet lab procedures. And for those, this run button, talking about dynamic and interactive methods, this run button is another really nice feature that I invite everyone to explore that allows you to step through the protocol, sort of like a cooking checklist app where you see where you are, what you're doing next. You can start a timer right in the fume hood on your tablet. And if you change anything as you're running through the protocol on that particular day, you can capture, oops, today I did 25 degrees instead of 30 degrees, or I dropped to number 17. So it's sort of like a lab notebook component, and then you can export that record, print it out, put it in your paper, or export the PDF and drop it into your electronic lab notebook. But this allows you to see how exactly you ran the experiment on that particular day. And before I stop with the live demo, there are just a few small things that I wanted to highlight in terms of the workspaces and the organization specifically for industry use. And so again, just as the protocol that I highlighted, that was an example of a public protocol, but most of the workspaces that we have are private and secure. So this is an example of a public workspace from the US FDA pathogen surveillance group. And what you can see is that the protocols are not just sitting in a giant repository, but the protocols are organized in a community, in a workspace. So at your company, you can imagine your entire team having a workspace dedicated to your specific, whether you're in the vaccine division or immunotherapy division, with your specific team. You can have a workspace, you can have multiple workspaces with other collaborators, and it allows you to organize all of the protocols in one space. In this particular workspace, there are 200 members. You can see all of the discussions that are happening around the methods, all of the methods that are organized here. Um, and when you click on the group folder, that takes you to the protocols.io file manager. And this is an example of a demo group that I created. But what people frequently do in the workspaces is create a structure with folders and subfolders to organize the protocols. The old ones move to archived. Here's a folder with protocols that are in development, and then you might have one that is tested, verified, and approved. The workspaces and the file manager have a lot of flexibility in terms of the administration. So the person that creates the workspace, just as on a specific protocol, in this case on the workspace, can set permissions, who has access, what type of access, what kind of behavior is expected, what are the instructions for using the workspace. And again, this is just to highlight, this is the place where you organize the protocols in a central location. You know what's where within your team. And if someone leaves, the protocol is not leaving with them or getting lost on their laptop. Whether or not the person is there, the protocol remains in the same location where you can find it. It's versioned, you know what the most recent variant of it is. And you can go back and forth between the discussions, the organization of the protocols, and the file manager view. And here is just another example of a workspace that got started in response to coronavirus research. And you can see there's over 500 members, 200 plus protocols inside their group folder in the file manager. And again, the benefit of this is people that are part of a workspace, not only do they see the discussions, but when new protocols come in, when there are forks, when a new version is added, everyone who's in the workspace is notified. So it's a way to stay on the same page and be up to date as a team in terms of the method development. And I think those are the key things that I wanted to get across in the live demo. And just to finish up, so it's a central place to organize, and it's like Google Docs, but really optimized for capturing reproducible, detailed protocols that will facilitate teamwork and collaboration. And here's a wonderful quote from CEO of a biotech in Oakland, who said that having a workspace on protocols.io is indispensable to our biotech. We use it daily to help with reproducibility and collaboration across our multiple locations. And as I finish up, one of the things to highlight is that because of the government agencies and industry partners that are using protocols.io, because of the sensitivity even in academic labs to the intellectual property that's in protocols.io, we take security and data integrity very seriously. There are constant backups every couple of minutes. We have amazing uptime. We've integrated with Google Drive, Dropbox, Open Science Framework, and many others, so that you can take all of your protocols with a click, export an entire folder into your Google Drive or Dropbox so you have redundancy, or download it to your computer. Workspaces for extra security can turn on two-factor authentication if that's relevant. Obviously, everything we're on Amazon, everything is encrypted. We have strict policies at protocols.io so that even we cannot access your private protocols until you decide to share them or make them public. And over the past year, we've added support for HIPAA compliance and electronic signatures and audit trail 21 CFR Part 11 as part of the enterprise version of protocols.io. And there's more information in our FAQ. And as I finish up and open to questions, I should also say, again, if we don't get to one of the questions that you put into the Q&A in Zoom, you can always email me directly or email our amazing customer support at info@protocols.io. Also, because I couldn't really show a lot of the features that we've developed since 2014, I didn't dive into the editor or really take you through the file manager or show you how the 21 CFR Part 11 workflow looks. You can always go to protocols.io/help/demo and pick a 30-minute slot to get on a call with our customer support on a Zoom call, and we'll share the screen, answer your questions, and you can also, if what you heard here was relevant, you can also reach out to us. We can run a session like this specifically for your team, for your teammates, instead of you just circulating the video. So I will stop there and go into the Q&A. And you should feel free to either put it into Q&A, or if you'd like, well, we have a lot of people. If you're brave, you can unmute yourself and just ask, or you can put in questions into the Q&A. All right, so the first question. So the first question is, how are your pharma company clients integrating protocols.io into their workflows? For example, with existing LIMS systems. So that's a great question. There are a lot of enterprise customers that are using a specific lab notebook or LIMS system and also using protocols.io. As I briefly showed, but I didn't highlight it, we have a very well documented, really good public API that allows customers to connect with protocols.io from their existing tools. There are 2 electronic notebooks that have integrated with protocols.io. And so it's both from our side that we make all of the exporting easy, like I said, to Google Drive to your computer, but we also welcome those integrations. And it's not either or, you're still using GitHub and you're using protocols.io. So it's not like there's one tool that covers everything. And since we launched in 2014, we're only seeing more and more of that federated approach where computational teams are using one tool for the repository for the data. They're using GitHub for code. They will detail the computational workflow on protocols.io, and that integration and communication between the tools obviously is very helpful. And then there's a question, are there common instruments integrated with the SW? So I'm not sure what SW is. But if I'm getting this question correctly, we have dreams about integrating protocols IO with equipment, with the instruments in the lab. So imagine coming to your centrifuge and it knows that you're on step 17 of the protocol that you're using, and it knows what the setting should be, and you're not going to turn it on at the wrong speed and burst all of your cells and lose what you were doing for a week. We're not there yet, but this is something that we're really excited about and hope to work on in the future. And then there's a question, what is the strategy followed to extract protocol details which are at the reviewer or editor level to put it into protocols IO? So we actually do not have machine learning to, that's a great question. We don't have machine learning to take published research papers and extract the protocols from them. So what you see in the repository, the 11,000 protocols I talked about, that is crowdsourced. So that is authors themselves taking their Word document or just drafting the protocol directly in Protocols IO if they're using us from the beginning of a project. But the public protocols that you see have been entered directly by the authors. That's why you can ask them a question. So these are not methods we're pulling out of previously published papers. And one of the reasons for it is exactly that point, that most papers actually don't have, the method section has some of the information that you would need, but just as we saw in the example with the cancer biology reproducibility project, most papers do not have the detailed protocols in the method section or even in the supplementary in a way that would make it easy for Protocols IO to pull out that information and enter into the public repository. So we rely on the journal partners, those 500 plus biomedical journals, to encourage authors to put the detailed protocol on Protocols IO and then link to it from the method section of the paper. Thank you for the excellent questions that are coming in. And then another question, while you are while we have a pause in questions coming from the audience, another question that I'm not asking myself, but that I know comes up frequently, or at least people think, and sometimes they ask, because we are a private company, we're a startup, there is a question of what happens if you go bankrupt? And the answer to that is, we've been around since 2014, and as a startup in the first few years, there was a lot of touch and go where I was afraid that we'd go bankrupt, but we didn't. And I think with every year and every month, the probability of that happening rapidly decreases. So we've been pretty stable and lucky with the support and funding and the business model that we have that allows us to get to sustainability. But past performance is obviously not indication of future success. And so we do constantly think about having the trust and ensuring that if you're using Protocols IO, things suddenly won't disappear. And that's exactly what the export is for, what the public APIs are for. And we do everything that we can with those integrations and with the backups and export to ensure that, even if we're down for a couple of hours, you have your protocols mirrored somewhere. You can always get to the details that you need for running your experiments. And our uptime has been fantastic over the past years. And then there is a comment, hey Lenny, thanks for the demo. Great to see the steps you and your team have made. And Fane is one of the former ambassadors for Protocols IO, who was giving us a lot of input and advice into improving the platform. in the earlier years. But the question from Fane is, how does Protocols.io platform deal with different fair data principles or industry standards, mainly for biopharma, to enable collaborations? And I don't know if our director of strategic initiatives, Dr. Emma Gannon, is on this call, but she was the former editor-in-chief at PLOS Biology before she joined Protocols.io 2 years ago. And we think a lot about the FAIR principles. We follow all of the best practices for mirroring the public content, depositing it for long-term preservation, registering and cross-ref the DOIs to make the public protocols citable. And from our side, we do everything that we can to make sure that what is shared complies with the fair data principles. But at the end of the day, we're not a journal, so we're not an editorial team, and we can't review everything. So we can build the platform and give you the tools that allow you to share things, in reproducible and in ways that comply with the best practices, but we don't have the capacity to track it. So we're really, for the open sharing, we really leave it up to the community to ask for improvements, to put in comments, and then a lot of the protocols that come into Protocols.io from academia, a lot of them actually get published in journals, and the editors there and the reviewers on that end are hopefully checking. But in the Q&A discussions that you see, that's where frequently improvements come in from requests in the community. And then there's a question, Blue Sky, what does Protocols.io look like 5 years down the road? And that's a good question. So one mission critical part is making sure that we're around in 5 years. And as I said, we've been here since 2014. So that, I think, is much less of a concern now than it was back in 2015. But in terms of what are some of the biggest things we're aiming for, I would say that we have a lot of adoption in biomedicine among biologists. We need to do more to branch out into chemistry and get chemists onto Protocols.io. And we've started over the past year to add chemistry-specific components, but we need to do a lot more of that listening, getting feedback and input, and optimizing the platform for chemists. And of course, the other part is there are, in terms of growing the knowledge base so that most of the protocols that you're looking for are already in Protocols.io. It's great that we're on a good trajectory. It's great that we have 11,000 public protocols, but we have a long way to go in terms of going from 500 journals that recommend us to 5,000 journals, because there are many more journals just in PubMed alone than 500. There's about 1 million papers that get published every year. And so ideally, in 5 to 10 years, we get to a point where not every paper has a link to Protocols.io, but the ones that do, the ones that need to have it do, and we get to a point where it's not 11,000 total public protocols, but we're getting 11,000 or 20,000 at least per year. So I think increasing the adoption awareness of the existence of Protocols.io is one of those key challenges for startups, even those that have been around since 2014. So I think we've had several million scientists on Protocols.io over the last couple of years visiting and using the platform, but that's out of 15 million worldwide researchers, right? So most people still have not used Protocols.io. And let's see, any other questions? I think we are coming to the end of the webinar in terms of time. But as I said, let me just share once again. My personal email is lenny@protocols.io, and you can always get in touch with the entire team at info@protocols.io. It's monitored and we respond pretty quickly. And as you play around, you should feel free to request a demo or get in touch with us to set up a demo session and Q&A for your team. All right. Thank you, everybody, for joining, and have a wonderful rest of the week.